And now I'm looking at the HNMR and I labeled it.
Which OH is that, of the carboxylic acid or the alcohol?
Alcohol.
I agree.
Because it can't be a carboxylic acid, so I'm given one oxygen in the.
Yeah, and also there's no carbonyl.
Yeah. And then I started labeling like doublet, triplet. The one all the way upfield was a triplet. The one next to that is a doublet. The one at about 1.5 is a multiplet.
Yeah, but you can count it here.
Yeah, I counted like 8.
I see 8, but sometimes baby pigs hide down there. Let us for now say that that's unmultiplet, but specifically an octet, and it's gonna be equal to what?
7.
Okay.
And then the one at 3.5 is a singlet. The one next to it is a septet. And then I just need to try and remember what is at these points.
So far, that's good brain process. Okay.
I'm gonna assume that the singlet at 3.5 is the alcohol.
Yes, we can assume that, but sometimes it hides.
And then I think that the
exchanges with D2O. So yeah, this information tells us that's an alcohol because it exchanges, it hides.
So what I said about that being an alcohol is wrong.
No, that's correct because the information is telling us that whatever hydrogen is here, hydrogen bonds with the water, with the deuterated water. So it has to be OH.
Got it. And then I'm gonna say that this triplet upfield is our CH3, and the one next to it, the doublet, is CH2. That makes sense. It's the N+1 rule.
So what are you saying again?
The triplet all the way upfield at 1
Mm-hmm.
is a CH3. That's going to be connected to a CH2 because of the doublet and triplet.
How did you know it's a CH3?
Because it's a triplet, and with the N+1 rule, it would be 2 plus 1 to make that a triplet.
All we know is that the N is 2, but we don't know if it's a CH3.
Okay.
You have to use depth information. Is there depth information here? No. Oh, this says carbon proton coupled.
Do I look at the proton coupled or the decoupled?
Proton decoupled. You look for the proton coupled. This is just normal. There's another question with depth. I'll bring it up. This does not tell us if we have CH3s or not. So
should I just start drawing now?
What is the fragment here?
45?
Mm-hmm.
I have no idea. I guess I could do 45 minus 16 with the oxygen.
The M plus supposed to be 74. So what was lost here was 29?
Yeah.
And that is CH3, CH2 lost. So you have this fragment. So that tells me that you should be right to say that you have a CH3 next to a CH2.
Okay.
Just based on the fragment lost. So you see, MassSpec can help you out. Okay. And then, so where is this CH2?
I think it's I was gonna say that it's this doublet right here next to the triplet.
It cannot be a doublet if the triplet is there, because it's at least a quartet. This right now is a quartet, but we know there's something else. Yeah. So it cannot be a doublet right now. So let's see.
I don't know if this multiplet thing is going to be.
This sextet is a type of a hydrogen next to an oxygen, right?
Yeah.
Because of the 3.5.
I'm gonna start drawing it and then see if I can start to match up the pieces.
Yeah, I think that's the best idea. So could it be that you have an OH here?
Yeah. That's so far what I have drawn, but I'm gonna check.
Then we have one more.
And yeah, the CH2 isn't gonna be a doublet. Because there's a CH3 next to it and there's also a hydrogen.
If you put a hydrogen here, this CH2 has N equals to 4.
Yeah.
So it's supposed to show up as a pentet. But you told me that it's supposed to be a sextet. We have 4 carbons, remember.
Yeah.
And that will mean that whatever is out here must be a CH3, which probably does the one that's going to be a doublet. See this? N equals to 1. So M will be equal to 2. So this could be a doublet. Let's just pretend you're working with what we have. This could be a triplet. And then this one has N equals to 5. So M will be equal to 6. So, and since it's close to the oxygen, is the one that's going to give you the sextet. Question mark is here.
Wait, how does that equal 5? Because 2 plus 1 is 4. Am I missing a hydrogen?
You have 2 hydrogens here, you have 3 hydrogens here. Doesn't that make 5 neighbors? For the hydrogen. So M will be 6 for that hydrogen. The issue is this octet.
Yeah, I'm not getting that at all.
Let's look and see.
Is it okay if I get CH3 on 2 sides? I'm gonna have to.
No, it makes sense because no, these hydrogens here, they are none. These hydrogens here are what? They're diastereotopic, right? These hydrogens are diastereotopic. So one is gonna split to a quartet.
Oh, I found the doublet.
You're still on the doublet. We finished with the doublet. We said the CH3 is a doublet. We said the CH2 is a doublet. So I'm talking about the CH2. Going back to...
Yeah, that's the pentet thing. That's not what it's called, is it? Quintet.
What?
I'm getting 5 for that, because it's 3 plus 1.
Yeah, that is what I'm trying to explain to you. There could be an effect of diastereotopicity, because these 2 hydrogens will see different things. If you replace this hydrogen with the bromine, and then again replace the other hydrogen with the bromine, keeping this constant, you get them diastereotopic, right?
Yeah.
So they're different, so they'll split each other. So imagine this being split to a quartet, but because there's another 1 there, N equals to 1, the quartet becomes multiplied by 2, you get an octet, and that is the effect of diastereotopic hydrogen. So this has to be the structure.
Okay.
So anytime you get a confusing peak like that, assume that it was multiplied by a factor. Most likely they're diastereotopic hydrogens.
Okay. So then in this case, the CNMR didn't really do anything.
No, usually I rarely even when given depth, I rarely use it.
Okay.
I rarely even use mass spec. But now once you have the structure, you see it makes sense because
Yeah.
you can do an alpha cleavage of this to lose it.
Like that. Okay. That makes sense.
Yeah, and your 45 is gonna be the CH3 to CH to OH plus dot. 15, 13, 18, 17. See?
Yeah. That makes sense.
Yeah, so we did not have to use the UV because we've not memorized those numbers anyway.
Yeah.
I'm going to give you another one.
Okay.
Unless you're scared.
No, I'm not. I actually really like doing these.
Then we'll talk about some deals, cycle additions, then deals order going backward.
Yeah. I feel like that's my biggest concern is like the cycle addition stuff. Like when we get to it, can we do the one that like polymerizes?
Yeah, the phenol one.
Yeah, that one is like the most confusing thing to me right now.
Let me see if I can find a depth one. This is good. 7.
And I did a bunch of the like other problems where he just gives us a list of the HNMR and stuff and the CDEP stuff, and I was getting those all right. So I feel like I'll be okay.
Okay. So we are checking off the list to make sure.
Okay.
Just to make sure. Screening concepts.
I need to do good on this.
Yeah. You told me it carries more weight.
Yes, unfortunately. And I feel like this is, I don't want to say it's easier, but I know the intermittency stuff is going to be really bad. So.
Oh, the coming exam is going to be something, I'll tell you that.
Yeah, so I'd like to do well on this.
Maximize.
Yeah, there's one exam I can do bad on. You have to work the exam. So, yeah. Right now, none of mine need to be like pass. So, that's fine.
Okay, so I've sent you the next question on Wisant. You can pull it up. Start working on it. I'm going to share my screen. This time we have 6 carbons.
I got an IHD of 2. There's a C double bond O, and I think that's an sp3 CH and IR. Or would that be sp2 on like between?
No, this guy is questionable.
Okay. And there's no peak for.
Wondering if is that an aldehyde?
Yeah, is that?
So that's a twin peak. We see that we have a carbonyl, so does NMR have a peak around 5, 6? It doesn't.
No, so it's not
So that is, no, I'm saying aldehyde should show up at 9.
Yeah.
Do we have a peak? No, we don't. So that's just noise.
The peak at 4, could that be a ketone?
And there's no sp2. Peak at 4. Peak at 4. No, that is as most likely a CH3 next to an oxygen. Remember, if you are to think of carbonyl, you are looking for alpha carbons, but we'll see. II is only telling us right now we have a carbonyl. We don't know how many. Usually if there are 2, it usually splits down there somewhat
Okay.
if there are two
You have
carbon.
like an ether or something.
No, it's must. We have a carbon. It cannot be an ether. We don't have a carboxylic acid. Most likely an ester.
Okay.
Maybe a diester.
Um,
Look at the depth.
oh, I started with the HMR, and I
Okay.
got that there's a doublet, a singlet, and a quartet, or a doublet, quartet, singlet.
I agree.
And then, yeah, the C-depth shows that there's a CO bond, and it doesn't, or I guess the one that's, am I allowed to look at the decoupled one? Because that shows that I'm going to have, this one's 70.
That's just the carbonyl.
Yeah, that's what I was going to say, but, so it can't be a ketone or an aldehyde, though, because that starts at 1.
It can be a ketone, but because we have so many, because we have so many oxygens, I'm nullifying the ketone. Definitely not an aldehyde because we don't have the peak at 9.
Okay.
So we probably have CH3. There's no CH2.
Yeah, so there's no, okay.
There is no CH2, which makes it even crazier. We like to build our chains with CO2.
Oh my god, there has to be symmetry, no? Because there's barely any signals.
Yeah. So,
You agree with me?
yes. So
Okay.
maybe, I don't know if we have 2 of these.
Yeah, there's no carboxylic acid. That would make my life a little bit easier.
Is a quartet, so N equals to 2. Here N equals to 1. Here N equals to 0.
Yeah, and the IHD was only 2.
And there's no CH2. Wonderful. Very, very wonderful.
I really don't know.
You know, I'm thinking of this one here.
Yeah.
If I can put a CH3 in the middle.
To get that hydrogen to get the singlet.
Yeah, to get these to be a D and to get these to be a Q.
These are hard.
Thank you. And then that singlet must be close to the oxygen, so look for symmetry and put that there. And that will solve it. That's 6 carbons. Ooh. Yeah. If someone gets this right in your test, they studied or they are lucky. But kudos to you to know that there was symmetry because there was very, very few peaks.
Yeah.
Usually it breaks down here to know if we have 2 carbonyls, but well, I guess it does. I guess it's splitting down there. The carbonyl on IR. 10 hydrogens. Yes, those are 10. It has to be that because there is barely no CH2.
Yeah. 3, 6, 9, 10. Yeah.
You see how this integration is twice the other one?
Yeah.
So
Does that show symmetry?
if this is CH3, no, it just tells me that these are 6 hydrogens.
Okay.
Well, it's a ratio of 1 to 2.
Okay.
And then this is barely down there. So this can go here maybe 6 times. I don't know.
Okay.
I don't think it
I
goes
hope I
there.
get this one on my exam tomorrow so I can get it right.
All right, so
This helps me for a while.
this one will make you sweat. But that is the structure anyway. If you get one with few peaks tomorrow, big hint is symmetry. So you may want to double your carbonyls or your double bonds, whatever it is, you may want to double them.
Got it.
Okay, now so let's now go to the other ones. So if you're given this structure,
This is for the polymerization one.
yeah. So you need to get the ketone intermediate as a guide. This is just a guide, then you get the final.
Okay. That's always the case.
They will not ask you for the intermediate. That's you to know that you should always go through the ketone.
Okay, got it. Where do I like start pushing arrows?
You always start from the oxygen to give the oxygen a double bond. You can start from anywhere as long as. Let me give you a review so that you can see if you can apply. So usually if you have this, I can attack, okay, my double bonds are misplaced, and that's what they'll do to you in the test. So make sure the double bond is well placed, usually to the right, and the same thing there, I did it intentionally. So you want to attack this double bond first. Then from there you kind of do the cycloaddition process.
Is it always the one closest to the oxygen that is
Correct. Whichever way they draw them, you can redraw the ring yourself. So this used to be our arrow 1. The double bond went up there. So if I call this ABC, and now I have my ketone for this overview. And then this is gonna go undergo, this would then undergo tautomerization. Man, what's wrong with my stomach? I just ate. I'm hungry again. Don't blame myself, I've overworked today. Yeah. So this is where you end up. So hint, redraw your double bonds to favor you. I like relabeling. So make sure you are like daughter, like father. You do what I do. Only the good examples that I do. Don't follow my bad ways. ABC. So kind of curve it, because remember how you asked me, is it always the double bond that is close? Yes. Yes, it's always the double bond that is close. Yes, and yes, and yes, and yes. Why?
It like looks ugly. Like I got the ketone. These are the ketone ones.
For the original problem or for the example?
Yeah, for the original one.
Okay, so I'll attack
It
here.
looks ugly.
It's okay. I'll attack there. This goes here, and this gives me my ketone,
Yeah.
which will kill the double bond to the right.
I drew it on the left. Is that bad?
As long as you get a product similar to mine, the single bonds usually rotate. So you're getting a bond there, here, and here. Now, if you drew it to the let me draw yours. It should look like this. Yours should look like that if you did it right.
Yeah. Okay. I lost the carbon. That's what happened.
Did you label ABC as your guide?
I was. I labeled it wrong.
Because you're going A, B, C, D, E, F. D, oxygen is part of what you should label to give you a six-membered ring. I usually run away from numbers because someone would think that I was doing IUPAC numbering. But anyway,
Oh, okay.
A, B, C, D, E, F will help you. So you should get here, and then all that is left will be our tau memorization.
Just turning it into an LE.
I'm going to give you another problem because you asked for my help. Two more I will give you.
Do you think I'm gonna get one of these in my major products section?
It's coming. I don't think this will come in the mechanism. It's too short a mechanism.
Yeah, he said he's not putting any mechanisms, it's just for major products, that's it.
Yeah.
Trying to think about
I think will be predict product, and this time most likely it's gonna come as a multiple choice, and if it comes like that, good for you.
like this one?
Yeah.
Like,
You can come, I can put this on a multiple choice and just draw wrong structures. And that will still gonna be confusing, but that will be advantage. Huh?
major products, it's probably gonna be like a 1, 2, 1, 4 add up, so you know your temperature, so okay, for the temperature one.
Everything will be given, yeah.
Right.
Yeah.
And then, what else do we learn? A regular, like one of the easy DS alders. And then, what are the hard ones?
And retro.
Yeah, the ones that
We are getting there. We are getting there. We are getting there. First, please me by doing the right thing.
Let's see, these ones are hard.
Please me by doing the right thing here.
As long as I know how to push arrows, I'm usually okay.
Okay, try that. For your information, just guide yourself by seeing the ketone, because once you see the ketone, you will see the final product.
That's what I was talking about. The ones that are like, you count the number of pi bonds to see if it's
To see if it's
or con. Those. That was what I was thinking about.
to see if it's what?
Like the dis or con thing. With the
Oh, this and con, yeah. Those are coming. At least two problems.
That
Yeah.
I'm expecting.
We'll do those after this. We are going backward. So I guess it really snowed.
Here, yeah.
Yeah. Okay. I need to look for another problem here. Alright, so ketone will look like this.
Yeah, I get that.
Good. So once you push your arrow one, the next thing you're just throwing your.
Okay, so like, I guess substituent goes where we lost the double bond. It's gonna go there, that way.
Yes, yes, yes. To keep the octet. Uh-huh.
I do it like downward. Is that bad?
Like this?
Yeah, I do it down like that. Is that bad?
No, that's fine.
Okay.
That's okay. And then you will do your tauto thing.
Wait, these are actually easy. Okay.
They are very, very easy. Like when you're
Like
used to
very.
it, you don't even need to see the ketone. You just know what to do. If you push your arrow, you know, I know where my. But I think it's good practice to go to the ketone so you see the whole thing. You don't miss any carbons.
Yeah.
So my
Yeah.
ABC that took part is there. So at A, I have that stretch. I'm gonna keep it and just put my dab on there. ABC. I usually look for the ABC only. Don't care about the rest. And the dab bond must come back because you need it back aromatic. So don't forget. You're trying to remove this hydrogen. Where we say that the oxygen will steal the hydrogen drops the dab bond. Okay, I think that's enough of that. Let's see another one.
So the final product is always a phenol with the 3 bonds around this.
Yeah, there's a way we can push this whole thing on para position, but your notes did not go that far.
Okay.
Usually it goes auto, then it goes para, but your notes did not go that far, so we just stop with the auto where your notes stopped.
This thing also confused me. Will it be specified if it's sigmatropic or whatever?
They will not tell you
Like, how do I know then? Because I feel like I'm
because
getting
it can be cut into equal half. And you can count 1, 2, 3, 1, 2, 3. Okay, so 1 prime, 2 prime, 3 prime, and then original 1, 2, 3. For 1, 5, you're really moving a hydrogen over from carbon 1 to carbon 5. It's very easy to tell. So, yeah. It's very easy to tell. This is different from this. You can see the double bond is farther away to the right. Here, the double bond is adjacent to the oxygen.
Can you do this first one?
No.
I don't know how to do this one. I promise.
You don't know how to do it. Okay, so start from the oxygen. Or let's give ourselves a good understanding. You see how up here we first started by closing the gap.
Yeah.
So let's close the gap always. Let's always pretend we are closing the gap. Right? Like that. Or you can do the other way, but you know, I think I like going clockwise. So let me attack this here as number 1. Close the gap. So tell yourself, close the gap, close the gap. And then this moves over here. But again, you cannot have 5 bonds on carbon 1. So this has to go up. We'll do a couple of these again so you can say, I see it's not difficult. These are easy. That's what you say. These are easy. So this is my carbon 1, 2, 3. And up there, that oxygen is called 1, 2, 3. But those were the prime ones. So we opened a gap on the left. It's kind of you're opening a gap on the left, closing a gap on the right. Now use the same concept to this guy. Heat. Draw your product. I'll draw it.
Does it just like flip, basically?
Mm-hmm.
I
So again, close the gap, move over, break the bond. Da, 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 da. So arrow 1, arrow 2, arrow 3, 1, 2, 3, 1, 2, 3. The ones are always where you're cutting your bond.
Okay.
The ones are always where you're cutting your sigma bond. So it's still a 3, 3.
And I know I messed up if I don't have 3, 3.
Yes. You should end up with, well, sometimes this is, let me show you something. Sometimes these are substituted. But all you care about is the guys that are taking part in the transformation.
Okay.
So if they are substituted, don't fret, don't freak out. It's the same thing. Yeah.
Can we also go over, I emailed my professor, but he didn't email me back. He's probably just an email, but the like bridge bicyclic compounds, we like didn't do them in class, but he likes to do that, where they'll just like show up. When do I, like, how do I know when I need to draw a bridge?
When actually I'll tell you the die in. When the die in is cyclic, you expect a bicyclic.
So if it's like a cyclopentane.
Yeah. So if you have such, then you know you're gonna end up with such. If you have such, then you know you're gonna end up with such. And yeah, we can take examples. Let's see.
So even if it's like a cyclopentane, it's still going to be the bridge.
Yeah, this is gonna give you the bridge. These are the bridges. They don't take part in the reaction. So my focus is just the die-in. Huh?
I can draw like the bridge with the pentene, whatever.
You don't need to draw the fancy one. Remember, just draw your wedges inside.
Okay. Oh, so I could just draw a regular hexagon, essentially?
Yeah, because you always make a 6-member ring correct. Remember to show your stereochemistry. They are always opposites to maintain the endo. And so the fancy way
Is
that
endo, I know endo is down, but is that wedge or dash?
endo usually we put the bridge up so that the group will go down.
Okay.
The dienophile group goes down, which is what I'm drawing here. You see that now I don't need to do the dashes because this is side view. 3D. This is what I call the endo.
So I would make the I guess the dying. That's where I would add the wedges connected, or I could do
The
both.
these were not used up. Those are the ones that will bridge up, right?
Yeah.
So
But
that's
then,
why
like,
you put the wedges, and that means F and E is always where you're going to define stereochemistry.
Okay, so that like little gap right there where the red is,
Yeah.
I need to have.
Yeah. You need you. I should clearly see those spaces.
Okay.
I know I'm not looking at what funny things you're drawing, but make sure you practice. Don't combine the wage to the red.
Yeah.
It's a felony.
Okay, and then I would do my stereochemistry as normal.
Correct.
And then, why did you make them dash and then the inside wedge?
Because
The inside's always
because
wedge,
I
I know that.
because I don't want the reds are not wedges, by the way.
Yeah, they're like black ones.
The black ones, because you don't want the big groups to be on the same side. That would be exo. They will crowd in space.
So
You see this? Has to be
Yeah.
far away from the black one.
Okay, so always draw that on the wedge, and then why did you do the other one in dash?
Because they have to be opposite. If they're wedge, they'll be too close in space, and it's like you clapping your hands. You want them to be farther away. Let me draw you the wrong one. I'll draw for you the wrong one, and you will see that there's a problem here. Even drawing itself is not easy. These are too close. There are hydrogens here, by the way.
Okay.
There's crowding in the exo, and in that case, you would have drawn it like this.
Okay.
But just showing the wedges does not give you that visual understanding of the crowding, because if you do wedge,
It's still crowded.
yeah, you're telling yourself that both of these are axial up, for example.
Okay. So endo just prevents stereochemistry.
That's the goal, yeah. There's another reason as to why we call it pi stacking in physical organic, but that's for masters and PhD.
Okay.
That explains the endo very well using p orbitals.
I'm scared for the p orbital questions I'm going to get tomorrow.
Those are the easy ones.
I hope.
I hope.
There's 24 points.
I hope. Drawing p orbitals is very easy.
I can draw p orbitals, but that's it.
Yeah, if you have 3 pi bonds, you know that you're going to have 6 p orbitals, and then you just dance with them to make 0 node, 1 node, 2 nodes. Homo lumo, it's coming.
I think I'll be okay.
You will just relax, drink water, carry your cup of Gatorade or whatever it is to calm you down. Unless drinks are not allowed in your class.
No, they are. I go to LSS, so I'm allowed to do whatever I want. Like, I can bring in, like, a dog for all they care.
Oh, okay.
As long as I'm relaxed, that's all.
Yeah, that's why I'm insisting. Make sure you're relaxed and focused. You got this. You got this, girl. You got this. You got this.
I think I'm just gonna, like, tell my lab professor I'm gonna be late, because last time I felt so rushed taking my exam, because I was trying to go to, like, before lab.
Yeah, you just tell me. You tell him I might be late. So if you end up being late,
not the end of the world. It's just lab. Like, it's not like ortho lab. Like, you can't be late to that. Like, my physiology lab, I could be late to.
Okay.
Um,
So that was the order, but I want you to do part B, unassisted. Think about it and do it. That's more technical than the first one.
yeah, that one was really scary.
I know, but try.
So this is just like
That's
exactly the thing my exam's gonna be like tomorrow. Like, the harder of like the things I've learned.
yeah. I'm like a bad dad. That's what my kids tell me. You're challenging us too much. You're expecting too much from us. We're kids. I'm like, you're kids, but the world does not know that you're kids. This world we are growing in fact, their generation,
Yeah.
you have to fight for it. No one is giving it to you in your hands. Nope. No, no,
Yeah,
no.
through the weekend when you get to college.
No, no. And I don't want them to just get stressed when they get to college, so I train them early enough.
Yeah.
I tell them, do your homework by yourself. Let it make you pull your hair out of your head before you come to me.
Wait, so am I?
Huh?
This one is hard.
I know, but try.
Trying very hard.
Try. You asked for it. Isn't that what you were saying yesterday, that I should bring you challenging questions?
No.
Now you're taking the words back.
Yeah, I'm stuck.
Okay, let's do it together, no problem. So the first thing I realized is that I'm given, this screen went bright. I have an Asus Pro because I'm an artist. I like drawing and painting. And the laptop just knows when I look away, the screen just goes crazy.
Oh, really?
It brightens and then goes off. Let me reduce it down a little bit. Okay. So I see that I can do resonance.
Yeah.
This is the most negative carbon. And I remember I gave you the idea on how to decide. You go negative, positive, negative, positive, see where the last negative is.
Yeah.
For this one, the nitrogen has a positive. So I'll have a negative here, then I'll have a positive here.
So
Then
how do I?
these
Okay.
two, huh?
I was gonna say, how do I know when it's like I'm gonna have to start pushing from the oxygen?
Because that's where you have lone pairs and that's where it's more electron dense.
So draw my lone pairs first.
Yeah. Octet. It could be oxygen, it could be nitrogen, it could be wherever. A hetero arrow, nitrogen, oxygen, sulfur. Most likely is oxygen that you'll see. And the last 2 days I showed you where the OCH3 was here. Right?
Yeah.
That you know, if OCH3 is here, you go negative, positive, again, you know, resonance is not supposed to go this way. Anyway, if you insist to go that way, you're gonna end up on a positive. That's not what you want for die-in.
Okay.
You want a negative on the die-in, so this will be the carbon of interest in that case.
Okay.
But since now you see how these are opposite, that's a problem. So you'll have to flip the dienophile so that the negative one and the positive one will be real close. That way you're going to get an ortho product, but a bicyclic because the die-in is a cyclo.
When does it, like, I remember in my textbook, when you start doing, like, the negative positive thing, you want them in the 1-4 position, so I guess para, because that's it's most stable. How do I, like, is that true?
It's not always para.
Okay. 'Cause I don't really
It
know.
depends on the structure. There, I know what you're talking about, but I don't want you to use that method because it does not always hold.
So don't
Yes,
think like I'm wrong.
don't think about the auto-para stuff. You just follow the rules. Where is my most negative? Where is my most positive? Do I need to flip? Or should I use them as they are? And you'll know you need to think about that when the in has an EDG and when the inner file has an EWG. That's the only time you worry about negative positive.
They have to be right near each other.
Thank you.
And it doesn't like alter anything if I flip it.
No,
Don't do anything. Okay.
no.
Oh, wait, I kind of got there. Like it's like I kind of knew it.
And so OCH3 will stay regardless of the resonance, and then your coveted wages.
Yeah.
And then,
No,
okay, if you know that, that's good. We just took care of that. You said you like drawing the cyclohexane because you always make a 6-member ring. Go ahead if you want to do that and label it. This is our A, B, C, and D. Our E and F should be on our dino file, and it has an NO2 because we flipped it close to the OCH3. Now the next thing you're worrying about is stereochemistry. I'll give this a dash.
Why?
I'll give it a dash because my bridge is a wedge. Remember endo?
Okay, yeah.
Yeah.
So since I flipped it and put them closer together, I know in my final product molecule they're also going to be closer together.
Correct.
Okay.
Because you're
So
connecting them.
Okay, that's why you were saying don't think about the ortho part.
Do not worry about all that because you've not perfected it yet.
Yeah, and 1-4 in this case would be wrong.
Thank you. It's a 1-2. I exactly know what you're talking about, and I have notes on that in my website, but I don't want you to use that right now. The exam is close. I want you to follow the process and just
I could do that.
get it instead of forcing your brain now to memorize something new last minute and forcing yourself to work while you have other things to perfect too.
Yeah, I'm scared, I'm not gonna lie.
I know, but yes, you've put in the hours, and not just hours, quality hours, not wasting time. Trust me, you have it in you. The curve is coming to your favor again, but before the curve, get the most you can to put you way up there out of reach.
Yeah, the last exam, like for this, actually, the highest grade was a 70.
Ah, that's scary. Now try this one. Um, okay. I need the product.
Is this, the heat and light one, where I count them?
Yeah. Nobody will write CH3 for you. If you want, you can write your own CH3, but that's not going to be given in the test.
Yeah. This pi electron thermo is this.
Thank you. So
Hold
you
on,
keep stereochemistry.
Okay, I'm just gonna cry if I was wrong. Trying to figure that out all day. I just remember it. Okay, and then this one goes counterclockwise. And the other goes clockwise. So just towards each other.
where he says he wants structures for the names, which chapters did you do on this part, or is it just in?
It's just dying. I think I'll be okay.
So remember to put your triene, diene, tetraene, and you put the numbers of where the doubles should be found.
Yeah. I did see.
Okay, see, you're closing the gap. A, B, C, D, E, F. Looks like I have a 6-membered ring.
Yeah. And then
A, B, C, D, E, F. And then something at CD, something at DE, and AF. AF closes. You're closing right here. And in you can do dash dash. This is meso, so you don't say plus enantiomer.
Okay.
Same thing with the next one. What do you think will be the stereochemistry for the next one?
Opposite. Or not opposite. Yeah, opposite. So it would be the one that's in would be peptides. Which one do I determine, or do they both split?
This is in, this is out. They started off trans.
Do I want them to be cis now?
Correct. You get the same outcome.
Which one of the
The reason is because I changed how the CH3s are facing.
Okay.
So you get.
It doesn't after, I just look at it and say, okay, these are both cis, so I need to make them trans. These are both trans, I need to make them cis. That's all I have.
That's all you need to know. Thank you.
Okay.
Yeah. So if you're going in, that is cis, or out, that is cis. And then look at the condition if it will flip it, allowed or disallowed, this or con. And that's it. Which is what I was telling you. Easy points.
I'm just so nervous, I don't know why. I'm the most scared for this one.
I think the one that is scaring you, the one that should have scared you most is NMR, but you have a good handle on that.
Yeah, I think.
The rest, they are doable.
Yeah, I think if I dilly dally a little bit, I can probably.
Yeah. So even pi bonds and its thermal, what do you expect?
This one's on, so the things are gonna change. So these are these cis or trans?
They are trans. You have in and out. Don't look at how they are pointing. Just know this is in, that's out, that those are opposites.
Okay. And then it turns into a 6-membered ring, right? Or does it say 4?
No. A, B, C, D. 4-membered ring. Because those I told you write CH3 yourself, then you know it's not part of the ring. And as you said, it's con, so trans must go to cis. Push your arrow, close the gap, make that there. AD closed. And you can do wedge or dash dash.
Okay. I'm a lot less confused. Thank God. I was worried.
Yeah, I'm telling you, you're fine. You're fine. It's just that you saw the last exam and you're like, no. This guy's gonna throw at us again.
I do not trust him.
Yeah. You have trust issues, so you want to prepare the much you can and be perfect.
Yeah.
You'll see I think once you do the first 2 questions, your blood pressure will go to normal, and then you start thinking normal. Do we keep the trans or not?
Yeah.
Okay, so even number of pi bonds we keep. So trans stays trans, out, like that. And this time you don't say or. You have to draw both because there's no internal plane of symmetry.
Before we end, can we do an enantiotopic diastereotopic? I think I got it down.
Okay, so
That's my biggest worry.
I'm gonna draw. Okay, I'm gonna draw the molecule, and then I'll point to a bunch of hydrogens. I'll call that A. I'll call this B.
I feel my heart racing. I'm like so afraid.
Like a baby. Do, 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 do. My kids, when they were younger, I mostly took care of them because my wife was at school and working. So if I want them to sleep quickly, I would lie on the couch facing the roof and I put them on my chest. It's not gonna take 2 minutes, they are gone. And then I'll be feeling their heartbeat. It's like I'm like, is this kid okay? I keep calling my wife. She's a nurse.
Oh my god.
I keep calling my wife. I think this kid is sick. Why? The heartbeat is racing like that of a rabbit. That's how kids are. Oh, okay. It took me time to get used to that.
Funny.
Yeah, their heartbeat is like and it's thumping so fast, and kid is breathing. I'm like, oh my goodness. Mm.
I'm
So
like scared.
tell me what A is, then tell me what B is.
I think A is diastereotopic.
Correct, because you already have a stereochemistry there.
Yeah. And then B is confusing me. It's either homotopic or enantiotopic.
No, you don't create a new chiral carbon there.
So it's homotopic. That's what I wrote down.
So it has to be
I
homo.
had that written down, but I got scared.
You got
Please
this.
touch my
You
phone.
got this. Okay, so again, I'll call these ones A, and I'll call these ones B.
Okay, so this is where I get confused. Because technically, if I make that a BR at B, the other ones are going to turn chiral. You know what I mean?
If you do what?
Like if I, like for B, like if I make that a bromine,
One of the B's.
next to it, the two next to it become chiral.
If you make which one? Which one are you talking about?
B.
So, you're trying to compare this one. So let's say you are changing B1 and B2. If you put a bromine on, call it B1,
Yeah.
it's gonna be like that.
Yeah.
Okay. You're not doing any changes anywhere else, just at B.
Oh, so is
You have to focus one set at a time. So the other one puts a bromine there. Do you think those two hydrogens are seeing the same thing?
No.
Yeah. Yet you have chiral carbons already.
So it's diastereotopic.
That is what we explained.
So
Yes.
the way that I was thinking about it earlier when I was doing problems was if I see it once and don't see it twice, like if I see it when I'm at the top and then I flip it and don't see it, that's diastereomers. That's how I was thinking about it. And then enantiomers, if I see it and then see it.
Yeah, if you see it and you see it again, and that would mean you only had one other. That means that you had this type. I think your statement is correct. If you had this type, then you're gonna see this is gonna see the wage, but this one is gonna see the dash. So they're an isotopic kind of.
To decipher between homotopic and enantiotopic, I can look for a plane of symmetry or look for a chiral carbon.
Correct. If it's achiral, it's homo. If there's plane of symmetry, it's homo. If none, go with the enantiomer. You got this. I keep telling you. A here is gonna be homo because you're not creating weight.
Yeah, it can't do anything.
No, it's not doing anything. So A is supposed to be homotopic.
So enantiomer doesn't make a plane of symmetry either, or it does.
Correct. It does not. It should not.
Okay. Okay.
The only challenge with rings, draw them as Haworth.
Yeah.
And like you said, if you see it and then you don't see it, you know you'll die. You got this. I'm telling you. But you still need to have those few exam butterfly fever to keep you studying, but it should not go overboard.
Yeah, I'm gonna be done with problems tonight and just look over like the concept stuff for multiple choice, and then I think I'll be okay.
You should be.
I don't think I have any more like questions. Do you think there's anything else I need to worry about? No, right?
No. Predict the product will be Dios Ada. I've shown you different versions of Dios Ada. Let me stop presenting. You did not do radical. Usually with this chapter, I usually teach it with the radical chapter where they have to use NBS, allylic, bromination, chlorination, number of monochlorinated, but you did not do that. The other multiple choice you're going to get is what is the homo, which is the homo, which is the LUMO in this orbital diagram.
Okay.
And you know you're splitting. Huh?
And then if there's light involved.
Yeah. If you have light involved, you're going from the original homo to the LUMO. It becomes your new homo, and now you look at the ends and see if they can do this, coming in, this, going out, con, for them to match. Those are the kind of variations of multiple choice he might ask. But to predict your mechanism, you say there's none, if there was a mechanism, it would have been all simple because it's one step. Cycle additions. I think that's it. And ranking problems. The best die in, most electron rich, locked in cis. The best dienophile, most electron deficient, and yes, that's it. Most electron deficient based on electron drawing groups. The most electron withdrawing groups is nitro, carboxylic acid, sulfonic, SO3H, CN. Those things are the electron drawing groups.
Okay, because they're electronegative, so you're going to steal electrons. So that's how you
Yeah.
about it. And then I know like the longer the chain.
The more the conjugation, the less the heat of reaction. And and usually that means that you're going to have a longer wavelength. Is it?
Okay,
so longer wavelength, so there'll be lower energy gap.
Okay. And a lower energy gap, does that mean more energy or less energy? More energy.
Less energy gap is less energy.
Less energy.
Yeah. Okay. More conjugated, more stable.
Okay, so less energy, more stable.
Yeah.
Increase in wavelength is a decrease in energy.
Correct. And that
frequency is an increase in energy?
Energy and frequency are directly proportional. Increase in energy, increase in frequency. Okay. But the point of concentration here is energy and wavelength. Okay. For UVVs.
I'm scared. It'll be
okay. Okay. All the best. Let me know how it goes.
Thank you. And then I'll reach out to you because I'm gonna go on break, but I'm gonna come back early to start studying so I can get ahead on that.
Yeah, you need to download first. Earth in physics we call it earthing, where you have a cable taking all the charges into the earth when a lightning strikes. You need to do earthing, so your brain comes back to ground state, and then we'll catch up on the big chapter.